This is the elevator acceleration project. Theory is that when you're accelerating upward on the elevator, you're going to feel heavier because you're feeling of the forces of the acceleration of gravity added to the force of the accelerating elevator. When you're accelerating downward in the elevator, you feel lighter because you feel the normal acceleration of gravity minus the acceleration of the elevator downward. You are moving at a constant speed in the elevator. You are feeling like you are your normal weight because you are feeling the normal acceleration of gravity without any added or subtracted acceleration from the elevator. Oh yeah.
So our hypothesis is when the elevator is going up, the acceleration will be positive and the weight of the person will go up. Our second hypothesis is when the elevator is going down, the weight of the person will go down and the acceleration will be negative.
For the elevator going up, our initial weight is 130 pounds, which equals 59.02 kilograms. The final weight of Joseph is 146 pounds. And here we converted both those weights into newtons. The initial weight was 578.5 newtons, and the final weight was 649.7 newtons. We used the formula net force equals mass times acceleration, which is the final weight minus, final force minus initial force equals mass times acceleration. So 649.7 minus 578.5 equals 59.02 a. So acceleration equals 1.21 meters per second squared going up. And for the elevator going down, the initial weight was the same, 130 pounds, which equals 59.02 kilograms, and the final weight when it's going down is 123 pounds. Here we converted them to newtons again. The initial weight is 578.5 newtons, and the final weight is 547.35 newtons. We use the same equation, net force equals mass times acceleration, which is final force minus initial force equals mass times acceleration. So 547.35 minus 578.5 equals 59.02 a. So acceleration equals negative 0.53 meters per second squared. Our first hypothesis was correct because when the elevator was going up, the final weight increased and then also the acceleration was positive. And then our second hypothesis was also correct because when the elevator was going down, the final weight decreased and the acceleration was negative.